We are interested in solving trigonometric equations. Now to begin with, we're going to solve equations whose values are on this unit circle chart here. And that will help us conceptualize what's going on before we start working with unfamiliar values that we get from calculators. So here's the problem. Find all solutions of sine of t equals -1/2. We had two different pictures that's from the other video. One picture involved the unit circle, and the other picture involved the graph of the sine curve. So here's our graph. We're interested in sine of t equals -1/2. So over here, we would draw the line y equals -1/2, and we'd look for all the points of intersection, and specifically we're looking for the t coordinates of all those points of intersection. In the unit circle picture, the sine coordinate corresponds to the y, the vertical component, and so we're looking for solutions that look like that. This is the picture that's easier for us to work with, so we're going to focus on this. The question now becomes, well, what are those angles? How do we find those angles? And here's where we're going to have to go back to our concept of reference angles. If we look at this value right here, sine of t, and forget the negative sign for a moment, sine of t equals 1/2. We can find on the chart that the angle is pi/6. That pi/6 corresponds to the reference angle. So in this picture, since we have solutions in the third and fourth quadrants built around this equation, we have that this is going to be pi/6, and we have that is going to be pi/6. And so then with this picture, we can now try to figure out what is this angle here, the third quadrant angle, and then what is this angle here, the fourth quadrant angle. So t equals, let's think about the third quadrant angle. Our reference angle was pi/6. We have to go this far, which is pi, plus pi/6 more, giving us a total of 7 pi/6. This other one, you have to go all the way around and then backtrack by pi/6. So all the way around is 2 pi, and then backtracking 2 pi minus pi/6 is 11 pi/6. Now these still aren't all the solutions, because remember we have to deal with the coterminal angles, and for the coterminal angles we need to think about adding and subtracting multiples of 2 pi. The way this is algebraically represented is something like this, plus 2 pi k plus 2 pi k, where k is an integer. This notation right here, k, sort of the sideways e, sort of fancy e thing, and that's a z with a sort of double diagonal bar. That's a fancy way of saying k is an integer. You could just write out k is an integer, and that's just as good. And so this is how we get all the solutions. We have to think about this unit circle picture. We think about whether we're looking at sine or cosine, because that tells us whether we're looking at vertical lines or horizontal lines. This tells us where we draw those lines. And then once we have that, we know that we have solutions in 2 of the quadrants. And from that, we have to then use this chart of values and the reference angle to build our way back using geometry to these solutions. We'll do a couple more examples because this takes a little bit of practice to understand. So here's another example. Find all solutions of cosine of t equals the square root of 2/2 on the interval from 0 to 2 pi. This extra condition is easily overlooked when you're working on these problems, so pay attention to the instructions. When we limit ourselves to these angles between 0 and 2 pi, what we're saying is we just kind of want the first angle, so to speak. So here's 0, and then remember to get to 2 pi, you go all the way around once. We're only interested in the solutions on that first revolution. So let's think through this problem. Once again, we're going to draw the unit circle. Cosine of t. Cosine corresponds to the x-coordinate, and the x-coordinate is positive square root of 2/2. So we're going to have a solution up here in the first quadrant and a solution down here in the fourth quadrant. And now we have to start thinking about the reference angle. So cosine of theta, square root of 2/2. The reference angle is going to be pi/4. And so in this diagram, that angle right there is pi/4, and then this angle right here is pi/4. So then the question becomes, what are our solutions going to be? What are our t values? Well, the first one is in this first quadrant where the angle is the reference angle. So we have pi/4. And this other one down here, since we're going for the interval from 0 to 2 pi, we start from 0. We wind ourselves around to this level, and the question is, well, what is that angle? All the way around is 2 pi, and back off by pi/4. 2 pi minus pi/4 is going to be 7 pi/4. Now in this case, we do not have the plus 2 pi k because we are limiting ourselves to this interval. If this line were not there, then we'd have plus 2 pi k plus 2 pi k, where k is an integer, to deal with the coterminal angles. Here is one more example. Find all solutions of cosine of t equals -1. Now again, find all solutions, and there's no limit to our interval, so we're going to have to find all the solutions. And this is a situation where looking at the picture is really going to help us see what's going on. So we draw our unit circle. We want cosine. Cosine is the x-coordinate. The x-coordinate is -1. Since we have a unit circle, that corresponds to that tangent point right there. Now, we try to do a lot with trying to set this up by looking at reference angles, the reference angle of 0, and things like that. That ends up being a lot of work for something that is very graphically obvious. This is the only solution. What is that angle? That angle is pi. So t is equal to pi plus, we have to look at the coterminal angles because we're not limiting our interval, plus 2 pi k, where k is an integer. Now in this case, there's only one solution and not two solutions. And this sometimes throws students off because you kind of expect things to fit in a pattern. But if you look at the picture, the reason why we had two solutions for other values is because if we draw a vertical line, let's say right here, there's going to be an intersection point in quadrant 2 and an intersection point in quadrant 3. As you move closer and closer and closer to this tangent line, those 2 points draw together, and right when it's tangent, those 2 points are actually the same point. And so you might think of this as pi plus or minus 0. And so that's sort of where we get just one solution. It's kind of very similar to the same thing that happens with the quadratic equations. That parabola, if you're thinking about the shape of the parabola, you have two solutions, but as this parabola moves upwards, those two solutions pull together, and then there's one point right when it gets tangent where there's only one solution, and that again corresponds to a plus or minus, well in that case plus or minus square root of 0. And so we have this sort of convergence of those two solutions in this picture. Similar thing happens over here if x equals 1, and then at the top here if y equals 1 and y equals -1. So those are just the special case. Don't worry too much about it, just focus on the picture. The picture will tell you whether you have one solution or multiple.